And our next speaker is Keith Moffatt, of course. I don't think I need to introduce him. Keith.
Thank you, Angie. And thank you for including me in the program. I've titled this in PM Memoriam, so Cambridge College sort of phrase. We usually say PM Memoriam Benefactorum, in loving memory of our benefactors. But in this case, it's in loving memory of Konrad. And I want to pay tribute to him. I say here, from whom I learned more than I could ever teach, and that is true. I learned a lot from my conversations with him over the years, since he first came as my research student in 1984. He took his PhD in '89, and then I've kept in contact with, very regular contact with him ever since. I describe him as the life and soul of the party. I think that's come across in the talks we've heard already. What a wonderful character he was, and always cheerful, never without a smile. It's not absolutely true. There was one occasion I can mention when he was in a rather anxious and distressed. Well, I'll tell you right away. It happens very often with research students when they get to the third year of their research and they realize they have to write a thesis. And I happened to be at a meeting in Les Houches. I was spent a term sabbatical in France. And Konrad came to that meeting, Les Houches, in the Haute-Savoie, beautiful, beautiful place. And I thought, wonderful, he's going to have a wonderful time on the snow. And he came, he was terribly distraught because he said, I don't know what, I've got to write a thesis, and this is my third year, and I'm into my second term of my third year, and I haven't begun, I don't know what to do. He was in a serious state. So I tried to calm him and said, look, Konrad, there's a wonderful piece of work you've done in your thesis. He was focusing on the other stuff. And I said, this is really what you want to focus on, and it was the kinematic part, the flow inside a sphere that has chaotic streamlines. Very, very interesting, as it turned out. So I persuaded him to go back to Cambridge and focus on that and do further computing. And Andrew has just shown some of the Poincaré sections that came out of that work. But I think that was definitely the best part of his thesis. The other work on magnetic relaxation in his thesis, I'll say something about. It was a bit more difficult, really, and I think he felt it was incomplete, and it never resulted in a publication. And part of the problem was that I then took on another research student, Dionysius Linernatos, who took up that very problem and carried it really quite a bit further. And but he does give every credit to Konrad in the paper that he published. Okay, let's see. Now, it's been mentioned that George Batchelor had a great influence in Konrad's life, as in mine also. This is the portrait done by Rupert Shepherd. It hangs in the new department now, in Pavilion G. It was done George retired in 1983, and this portrait was done during the following year. So it was the very year that Konrad arrived at Cambridge, and I think this is one of the best images of George Batchelor. That's a much earlier picture of George talking to the very famous Theodore von Karman. That was, I think, at the Marseille meeting on turbulence, a very famous meeting too. Which we actually commemorated again with a meeting 50 years later, again in Marseille, so in 2011. And here is George again with someone that Angie will recognize, actually with Vladek Fizhdin and Angie's father. I'm sorry, this is such a terrible reproduction of photograph. It must have been a very old one that I had and scanned. But it still gives the impression of a very detailed scheming conversation. George was a regular visitor to Poland at the biennial meetings every 2 years, and I think this must have been about 1980, this picture. He visited Warsaw many occasions, I say, and particularly 1983, and I think that's when he met Konrad and persuaded him to apply to Cambridge, or suggested that he should apply to Cambridge. I had been at 2 of these biennial meetings. The first was in Zakopane in 1963 with George Batchelor and his family. We drove across Europe, which was quite an exciting thing to do at that time. And then I was also at the one in Bielowieża that Patrick Wiedmann was at also in 1973, and we were just reminiscing about that recently. These wonderful regular meetings in Poland that gave an opportunity for the West to meet the East during the Cold War years, because many eminent Russians came to these meetings also. In fact, the Bielowieża meeting was the one where I first met Zeldovich, and also Ladzinskaya, who came. Now there's a better photograph of Angie's father, Richard. I think this was during the Warsaw Congress in 2004. But that is, what do you think? It looks right. The color of my hair suggests that it was 2004. And with Tim Pedley. So we were having a very nice evening, I think, at your father's house.
This is in our house.
Yes. Well, now these pictures you've already seen. I jumped to 1989. You've seen some lovely pictures of Konrad during his time as a PhD student in Cambridge. But I jumped just to this one because it was a memorable occasion at Margaret's home in Cambridge. This is my wife with her back to the camera here. Oops, sorry, that one. And the pointer is what I need. And again with Margaret and Carol and Ulla. And I was obviously having a lot of fun with these 2 wonderful children at that time. So it was this was a very important year for Konrad. Would this have been 1989? Did I get it right?
89, yes.
89, yes. So it was a year when a lot was happening in Konrad's life, as I will just explain in a moment. Here is his PhD thesis, Flow Kinematics and Magnetic Equilibria. So this is the title page. February 1989 submitted, and it was awarded, duly awarded. I was trying to remember who the examiners were, but I really don't know. I think perhaps Nigel Weiss was one of the examiners. I thought it was maybe Mike Proctor, who was knew everything about this work. But no. Well, you see this little tribute on the second page, and this lovely little poem from excerpt from T.S. Eliot, and this one I don't need to translate, if I could, for this audience. But Angie was kind enough to provide a translation for me earlier in the day today, and it's essentially saying something about coming out of the fire and destruction and chaos. The word chaos appears here somewhere. Comes an occasional diamond. Well, it's a little bit like, I don't know, this poet was a 19th century famous poet, but it's as if he was predicting the chaos of the Second World War in Warsaw. It could have been a prediction. Of course, Poland has always been a very turbulent sort of country, but particularly so during the Second World War conditions in Poland. But nevertheless, occasionally diamonds emerge from these dreadful catastrophes. And one of the diamonds is the resurrection, the rebuilding of Warsaw. Incredible. And the wonderful people that have lived in these post-war years in Warsaw. So now this also 1989 has been mentioned, the IUTM Symposium. And you'll recognize many of the people in this photograph. It's clear, but many of you are here. Some of you are here anyway. Some of you are here, but I draw your attention to, well, you see, Konrad is in what you might describe as pole position. He was like that, you know. He was on our organizing committee for this, and the local organizing committee. Here's people, well, Julian Hunt, here's Andrew, here's George Batchelor himself, here's Uriel Frisch, and who else? Atta is here somewhere, aren't you, Atta?
I wasn't there yet.
You weren't there yet? Not quite, no. I thought there's Renzo, right, Renzo?
That's right.
This is myself. Let me see, who else do we know? There are lots of people. There's my daughter Penelope, who was also helping with the social side of things. And so on. Here's Ed Spiegel, for example, over in the corner. There's Steve Childress, who was mentioned, who we had the meeting in Montana for many years later, and so on. There's Rusmaikin from Moscow. This was 89, of course, just before Perestroika, so it was or during Perestroika. It was a very, very critical time for the Soviet Union, but we had several, I think you see Ladizhenskaya is here. Actually, Abukov was at this meeting as well, but he's not unfortunately in the photograph. He must have played truant.
Is that me at the back here?
Keith, you could also point out Jonathan Mestel.
Oh, Jonathan Mestel, yes, is here.
Yes.
Yes, he with a remarkable head of hair.
Not anymore.
He was a chess grandmaster at this time. Very, very, yep, okay. So that is the best. Now this was the meeting. This was the volume of proceedings that came out with. This actually was in the proceedings. It was a paper with Frances Nex, and I think she actually did that computation. But this one is the one the type that Andrew has shown you, that blew the holes in the paper. But this one came out all right, and it's in the paper that we published in JFM on this topic. And this was all Konrad's work, really. Actually, it grew out of a paper that Mike Proctor and I had written a few years earlier on stretch, twist, fold dynamo. And we tried to create such a flow, stretch, twist, fold, with these three characteristics inside a sphere. And it turned out to be the first flow in a confined region that exhibits this phenomenon of chaotic streamlines. That is a single streamline which crosses the diametral plane 40,000 times and is obviously never going to close on itself. So it's chaos. This was emerging chaos, you might say. It is minimal sort of chaos, and it was Konrad who suggested this term of trans-adiabatic drift. There is an adiabatic invariant in this, which I won't try to describe, but there's a slow variation from one adiabatic surface to another, and this is the trans-adiabatic drift. As you follow the streamline and crosses the plane again and again, it slowly moves in that sense. Oops. That's, did I miss one? I think I missed maybe, I just missed one. This is extremely sensitive, as others have discovered before. This was 1990, so a year later, March 1990, George Batchelor's 70th birthday celebrated in the old theatre. We had a wonderful gathering of people who gave lectures, I think, over a 2-day period. This is George with his wife Wilma, and a gift from Barenblatt with his usual formality, giving a present a birthday present, obviously, to George. I think George is slightly embarrassed to receive presents. There were many of them. And here is Konrad, again in pole position, you see. This is a portrait of Eddington, incidentally. Okay, so again, shortly after this is, you see, I'm repeating the easy line as others, but it's, I think, what you want on this occasion, to show photographs and recall happy occasions. And this was in Santa Barbara, at a program at ITP. It's now KITP, Santa Barbara. I guess that was 1991, actually, the program, and the proceedings were published a year later, in a very efficient production of proceedings, I may say. But here's a photograph of, again, Konrad with Lindsay, my wife, and myself, and Pierre Comte, who was there, and my son Peter. So we had an evening out in some little restaurant in Santa Barbara, near to the Institute. And we had a paper in the proceedings on chaos associated with fluid inertia. This is actually quite an interesting problem. If you take two spheres and you rotate both of them about different axes with different angular velocity, then at very, very low Reynolds number, which means very viscous dominated, the streamlines all lie on concentric spheres. So it's certainly a regular flow. But if you take account of inertia, you increase, as we say, increase the Reynolds number. And here the Reynolds number is, I think, 20. Then the streamlines are influenced by inertia, and again, they exhibit the phenomenon of chaos, familiar now phenomenon of chaos. So that was chaos driven by fluid inertia.
And Keith, what's the lowest Reynolds number on this one?
The lowest, well, non-zero. It's non-zero, but again, it's very weak chaos if it's non-zero. Well, yeah, it's chaos. It is chaotic. But as you increase the Reynolds number, the chaos is a bit like that previous problem. It becomes more.
Will it become chaotic at Reynolds number equals epsilon?
Yes, it is chaotic. It's a chaotic flow, which is remarkable. There's no threshold. It is chaotic, but you'll get that sort of phenomenon where a streamline nearly closes on itself. You go round and round again and again. It takes a long, long time for it to migrate, to fill the region of chaos. Whereas when you increase the Reynolds number significantly, you get a more dramatic effect. I mean, there are many.
Is there a critical Reynolds number at which chaos?
No, there's no critical Reynolds number.
That's
Just
non-zero. Zero is the critical Reynolds.
okay.
In this case. Yeah, you have to read the paper, clearly.
Piece of time. First time
I can't imagine that happens very often. I think it would be one of the rare and hence very interesting cases.
All right, well, I'm glad to know that because this paper is not terribly well known, being in a conference proceedings, of course.
You can hear how surprised we all are that it's
Yes, you're
chaotic,
surprised.
it's
Is everyone
very
surprised?
low.
No, you're not surprised. You're surprised. You're surprised. Yeah.
Because I can think of many more situations where you can say however you like at lowest Reynolds number, and it always goes to the similarity solution and it's nowhere near chaotic. I can
Right.
think of many more like that than.
That's true. I see what you mean, yeah, look. Well, I don't know, there are not many situations where the solution is known to this degree. You see, at zero Reynolds number, we know exactly what it is. And at a small Reynolds number, we can then do perturbation, expansion, and so on, to get this sort of effect.
Would you like to be my graduate student? We can work on this together.
I'd love
It's
to.
exciting.
Keith,
Yes.
the fact it's chaos in the Lagrangian sense doesn't mean that the flow itself is complicated in the Eulerian sense, of course.
That, I suppose, is true, but it's a steady, this is a steady flow.
Yes.
So we're talking about a streamline, which goes,
Oh, it's
it's pretty
a
well
steady
spaced
flow,
out.
okay, yes.
Yeah.
See, I
But it's
think
like the
That's what I
ABC
should
flow,
have said.
which you regard as very, very low modes of, if you looked at it, it's very simple.
Yes.
It has chaotic streamlines.
It's got chaos. Yes, I see what you mean, yes.
Yes.
I should have said that these flows I'm concerned with are steady flows, steady but three-dimensional.
Yes.
There were previous cases of unsteady two-dimensional flows. The blinking vortex of Arak, for example, that was sensational in 1984.
But can I suggest a different?
Yes.
Can I suggest a different way of looking at this, Mike? And I'd like to know your view. Is that if it's zero Reynolds number, right, it's linear, and so it's definitely not chaotic. Now, what you're saying is that you don't grant U-turn, no matter how small it is, at least in this case, can change that fundamental property. That's fascinating.
Right. That's what I'm saying.
Yeah, because at zero Reynolds number, there's no mechanism for radial flow.
But why should that you don't
Yeah,
grant
it's,
no matter how
it's pushing
small
the,
it be?
there's a radial component of flow.
It's the radial component interacting.
Yes, that's what it is.
Look,
Yeah, you better look after it. Focus in the eye. Oh,
Who poked two in the eye?
It's okay, I can look after myself. I will have to reread this paper myself. So let's push on. These are two photos of my research group during you've seen the lower one. I should just say that it's quite interesting. This guy, Simon Judge, extremely clever man, but he didn't finish his PhD. I think he didn't like the problem maybe that I put him on, and he had decided he had better things to do. Well, now he has a high position in the Treasury, Civil Service Treasury, and he is responsible for the funding of all the UK universities.
But not the Judge Institute.
Not him, no, that's another judge. Yeah, and this is Peter Watterson, you may remember, I don't know, who Australian, and he did visit me again in Cambridge just about 3 or 4 years ago. So he's still
Who's
alive.
that young chap, Keith, on the left?
You talk about the hairline.
Yeah, I know, it's terrible, isn't it? But this was, this must have been about 84, 85, sometime around then. And this was another nice picture I think, Atta, you're in this one, aren't you?
I started there.
You just started, there you are. And here's Konrad, and this is Larissa Fredkin, and Paul Deller, and Chrysanthi Economou, who disappeared. This is a terrible thing, actually. Chrysanthi was writing up her PhD thesis, and I think she was at that very worried stage, thinking she wasn't going to, and I was perhaps putting a little pressure on her to get on with it. You know, I was worried about that, but she packed up her bags and left without telling anyone where she was going, and I've never been able to track her down since. It was a strange situation, but we published a paper later and put in a footnote recording the fact that she had done some of the early preliminary work on the problem. But I was unable to locate her, which is most unusual these days.
Did you contact her parents? Or?
Yes, tried everything.
And they haven't seen her?
Well, she's from Greece,
So
and
what?
I had no answer from Greece. So, and of course I would try the tutor in the college, in Wilson College, and they had no more success than I had. So it was one of these rather unusual situations. Please come in and find somewhere to sit.
She attended the ICTAM big congress, did she?
She was
She presented a poster or something like that. I
in,
think I met once.
yeah, I'm sure you did, around that time. I can't remember, in Kyoto maybe she was.
Or maybe.
I think,
Oh, yeah.
may have been that.
But one
Yeah.
could have some rather negative thoughts.
Well, one could, I know. But then there was no, I mean, eventually I think the police had got onto it and tried to track her. No success. Yes, but no, so I don't know. Anyway, that was Grisanti. She was very friendly with Larissa Fratkin, who's here. And Larissa, likewise, doesn't have any idea what happened to her.
Well, and that I can tell.
And you know.
So,
No?
that I can tell you. No, we don't have to do with it now.
Okay, to move on. Zakopane, wonderful place. In 2001, Konrad organized a wonderful IUTAM symposium there, from which emerged this proceedings, tubes, sheets, and singularities in fluid dynamics. And in fact, Konrad spent the following April 2002 in Paris. I was on leave in Paris at that time, that term, and editing the proceedings, which were published later that year. I kept a diary at that time. I see my diary entry, you can see it here. Sunday, 7th April 2002 in Paris, bought coq and made coq au vin, 1.5 bouteilles PM for Konrad and Margaret, who came to dinner evening bringing Polish mushrooms, chocolate, vodka. Vodka. They are at Hotel Lutèce. All very jolly.
I remember it was fantastic.
You remember that occasion?
Yes.
Very nice occasion. Then 2004, the Congress in 21st ICTAM in Warsaw. These are always planned well ahead. The next one, incidentally, will be in Renzo's city, Milano, in the year 2020. Would that be right?
2020.
2020. Not so long away.
So
So
you put in
please keep
pressure
the
on
date, keep the date in your diary. August 2020 in Milan. And Renzo will run the whole show. Yes, and here you see Konrad at hard work helping one of the participants in the, I don't know, the room where the lectures were prepared. This is the wonderful, is it a palace, Congress Palace, where the...
The University of Technology
It's
is
the
the main
university.
building.
And this is where it was held, I think. And here's, well, again, this was a breakout from one of the grueling sessions at the Congress. Konrad with Yoshi Kimura, and again Pierre Comte, and my daughter Penelope. And the two were partners over a very long period. So, yeah, do you recognize this little bar near, very near, I think it's in the main square of Warsaw. Anyway, it wasn't far from the Congress building where we met. Again, a memorable sort of week in Warsaw. Well, you've seen both of these photos before. Say, always love to come back to Cambridge, as we know. With me in typically happy mood, you've seen this a few times, and on the towpath, which Angie very kindly gave me a copy of this photo. Oh yes, I meant now. How's the time going? We're
Absolutely
we're
fine.
good.
Take as much time as you want.
I can just show you. I meant to. I have to escape for a moment from this because I wanted to transfer this little movie from an earlier. No, not that slide. Play. Now, this is the sort of thing that Konrad did with me much more recently, 2013, and it is relaxation of a magnetic field. In a one-dimensional situation, I won't try to explain, but these were little movies made by Konrad, showing how a magnetic field, which is unidirectional but a function of the x-coordinate, you release it in a fluid with very, very low density. So the magnetic pressure tries to equalize itself, and that's what happens. And you end up with this sort of situation where you've got, a current sheet discontinuity. So it was a nice, oh well, then we go on, I don't know, that I didn't want to get into. That was another seminar. But it was, I couldn't transfer that, I had great difficulty, you see, technical difficulty, to transfer a movie from one to another, I couldn't do it. Well, now, that, I'm nearly through actually, we want to be in play, don't we? Well, we're now in the post-Konrad era, really, and this is Christoph doing what he likes to do best. Where are you, Christoph?
Here, doing nothing.
Oh, you're right. And this is Christoph, as you may know, is a wonderful guitarist. And here he is at it in our home, and Lindsay is quite enchanted. And he's a wonderful sailor as well. He took me sailing in Santa Barbara. And we were very worried I was very worried about that because we got halfway to an island and it was getting dark already. And Christoph was determined to get to this island. I said, we can't possibly get to this island. We won't be back. We won't be back till about 5 in the morning. And Lindsay gets very worried about these sort of things. So Christoph kindly agreed to return at a reasonable hour. I haven't. This is this is Michal Braniski, who I've also worked with. Who, again, we thank Konrad for having introduced me to Michal and more or less sent him to do a PhD under my supervision in Cambridge. And he's terribly sorry not to be here because he's in the States. He'd already arranged a 2-week meeting or something in America, and he couldn't get back for this. But this is a photograph on the roof of on the Great Gate of Trinity College. We climbed up there, and this is with Yotaka Shimamura. We'd worked together on the problem of the rising egg, which is rather remarkable. Now that, again, is, I'm afraid, going back, I think, perhaps to, I think this is 2011, isn't it? It's the, yes, it's the ECT, and then there was now that I won't have time to show you, but you can find, if you take a note of that reference. But anyway, the proceedings of the history meeting were all recorded, and the videos are all on the web. It's a beautiful little piece of Konrad in action, introducing the whole.
Isn't this on your website?
No, it's not on my website. Actually, I can't.
But if you go on YouTube and you look for the history of turbulence meeting, it's there.
I thought if I clicked on that it might work, but it doesn't.
It should.
Oh yeah, well, yes it is. It's working. Hold on a moment, you'll see it. Actually, the funniest thing about this is not to watch Konrad, but to watch Uriel Frisch, who can never settle down. I want to go back, get the beginning here.
Yeah, if you click that.
Click that one. Here we are.
There we go.
Play all. Am I all right
You can
now?
expand it.
Yes.
On the bottom right?
This one?
Oh, no.
Bottom right.
Bottom right.
Right.
Right,
Oh,
it's
yeah.
there,
Oh,
full
to
screen.
That one.
Go back to the beginning.
You want full screen.
No, you have to.
And you want to go
And then
Oh,
no,
previous.
the other way around.
Right hand
Left
side
way.
and find the right.
Left.
Twice.
So shrink it again and look on the right.
Yes.
There it is.
I'm getting advice from every corner.
Just
Did you do a manager? You know how to do this.
There it is.
twice.
Oh, you see, you get.
Yes.
Oh yeah. He can do it. See backwards. This is the amazing thing. I just want to see a little bit of
Yeah.
Konrad,
Here it is.
and here we have him.
There's no sound.
Yes.
Yes.
For some reason the sound doesn't work now.
Where's the sound? Sound is on.
No, you have to switch off the full screen. And
So if you switch off full
for a
screen.
moment, could you?
That?
Yeah,
Exit
yeah,
the
exactly.
screen.
And now turn on the sound. Which...
My sound or their sound? This sound?
No, this sound is
Or
fine. No, the sound on the computer.
My sound.
Sorry. Yeah. For some reason it doesn't work now.
Yeah, it worked at home, but
Well, to make it work, we would have
Plugged
to
via
reboot
HDMI.
it.
well, you can imagine what Konrad is saying.
Lip
The
reading.
amazing thing is, look at this man. What's he doing?
Keith, is this in English or in Polish?
That
That's
is,
in English.
that
Well,
is,
no, he's asking us to imagine it.
that is Frisch. And Frisch never settles, no matter what is happening. Uriel Frisch is always, look at him.
He's concerned about some light.
He's
He has
fussing.
a light,
He's fussing, but he doesn't have to be
and then he
looking.
comes down and he keeps talking about that.
You remember?
I watched the movie recently.
It's unbelievable. It's unbelievable. But anyway, you see, you can find it. And Konrad gave an absolutely charming introduction to this whole proceeding. And all the lectures are recorded there. So I advertise this to you. Now, I think if I close that, I should get back to the wrong one. No, here we are. This is the one. Play. I'm nearly there. So tell me, yes, this is at the dacha. The dacha in your lovely dacha.
Yes.
You call it a dacha?
Yeah, you can say
Yeah,
that.
I can call it a dacha. Well, it is a beautiful place and a very happy occasion. This beautiful location, several miles outside Warsaw, where we were entertained royally, and here's the vodka, the traditional vodka. So, a memorable occasion. Now, the interesting thing is July, I come back full circle, because July 2012, and still Konrad is in this pole position. You see, the same repeat. From 1989 to 2012, he's still in this relaxed state. And this is another little more recent meeting we had with, here's Atta again, and Konrad, myself, and Larissa Fredkin, and Vincent Mack, who arrived, I think perhaps overlapped with you, Atta, and is now working at the Judge Institute in Cambridge. So again, you can recognize many people in this gathering. There's quite an overlap with the original 1989 meeting, I'm very glad to say. Now, there we're just about through. Well, that's with Yoshi and myself, actually in Edinburgh, at one of the satellite symposia of the Newton Institute. The
What's the
Edinburgh.
statement easy on the door, mate?
What is the, sorry?
It says easy there.
Easy. Oh, yeah, easy.
What's that?
I don't know what the rest of that. That's in the Salisbury Arms in Edinburgh. You have to go up there to see the rest of that. This is at the Newton Institute during the 2012 meeting. There he is chatting with Peter Swinnerton Dyer following one of the seminars at the Institute, and here he is again taking photographs. Oh, and this was at the Royal Society exhibition some years earlier, July 2007. I'm sorry, I haven't even had time to really edit these pictures, but that's with Michał Braniski, who was very much involved with, and Tadeusz Tokieda. And we set up a stall on the dynamics of spin. Renzo, Venice, 2016. Well, now that was a meeting that Konrad was also involved in planning, the early stage, but sadly didn't live to enjoy the benefits. But it was a lovely occasion. And you see, I was wearing the tie then that I'm wearing now, today. The reason was it was my birthday during that meeting, and I said to my wife, Linty, you would better go out and buy me a present. She went out to the Guggenheim Museum in Venice and bought me this tie. So I think that's it. He was a wonderful chap, Konrad, and well, I think his personality is shown throughout this afternoon's meeting. Now we go and have refreshments.
No. Not
Don't
yet.
we?
Not yet.
Not yet? Not yet. And she has other ideas. Anyway, thank you very much.
First of all, any comments or questions? I have a question. I think the picture you discussed in the beginning has also Mike Proctor, is it true?
Oh, yeah, Mike would be in that one.
And
yes.
was Arnold?
1989. 89.
Was George Batchelor?
Yeah, I think you were.
Oh,
And was Arnold there?
You may be right.
Why?
I was certainly at a meeting.
I think you were there.
Yeah. I'm in that picture.
Yeah.
Just to the left of the flag.
right, yes, yes. Let's have a look where Mike is.
I'm the tall guy at the back. Yes, Steve.
I was hunting. You out there somewhere, Mike? Let's see.
Up right at the top. Go to there. There you might be past me.
I
To the left,
passed
to
you.
the left, to the left, to the left.
Left. There you are. There's Mike. Yes.
I have some hair.
And is Arnold here?
I don't think Arnold was at this meeting. That's Zaslewski who was there.
Oh, George.
Yeah, George Zaslewski. And Aref. I think this is Aref here.
Yes.
He was there. And so many very distinguished people at this gathering, actually.
Yeah.
Yeah. That, there's a large-scale version of this that hangs somewhere in the department in Pavilion G, first floor. Yeah.
Are there any comments or questions for Keith? Okay, if not, let's thank him again. We, before